Okay, so today I did want to speak some about contracts and specifications, just a little bit more. We're leading up to a discussion on testing, and a module that will take us a couple weeks to get through. Really nitty-gritty issues with testing at different levels, at the unit level, at the unit integration, at the integration, and at the system level, and in some cases at the acceptance level. Um, Contracts and specifications provide a good backdrop for that discussion because they play such an important role for writing unit tests, for equipping the test team to write system tests, but they serve a role well beyond that. How can anyone say here, when we think about contracts and specifications, as I've introduced them, how do they aid a project? What are some of the beneficial roles they play in a project? Yes, Bruce.
They provide patient protection, clarity to the projects and
Okay, so that's certainly I would agree wholeheartedly with that. And if you know what you're trying to accomplish, you can better plan how you're going to do it. And specifications give that sense of what you're trying to do at a design level, much as requirements do at a level of sort of overall program functionality. Okay, you may have forgotten some things during the break, but so have I. Okay. Yeah, I know he has the hat, and that's helpful. Red hat man, no, oh, this is really embarrassing. Speak on you.
yeah.
Ronan, thank you, yeah.
I was just gonna add agreements and kind of promises, like contracts are kind of like that. Yeah, it's a promise we can work on.
That's right. And it allows different parties within the system to do work simultaneously, right? Users of that, maybe it's a function, maybe it's a class that offers these promises. That gives guidance to people building that class or that function. But then all the folks who have to use that know what they can count on, and so they can develop things in parallel with that. Because they know, what it does, what it guarantees, what it needs to do its job, and what it guarantees if given them. So it allows for some parallel development. Others, I know this is asking you to remember some things before the break. Alex.
It makes it more modular and as abstraction.
Yeah. So it fundamentally it helps realize modularity, and abstraction helps build up these pieces of the system that accomplish work that represents some sort of common tasks, for example, used many places, right? So here we are going from sort of a situation where we have many different uses of things that are pretty much the same. Like, and I had so where is that slide? It's in here, but it's probably hidden. We have many places within the program doing the same sort of thing inline. If we have this, we are duplicating some unit of work in many places in an implicit way. And by carving it out with a function that actually accomplishes that, we can reuse that function. We only have to modify things in one place, right? And there's many parts of the program that by making use of this, can allow the developers to focus on their areas of the code which use this rather than the detailed logic within there. So it helps divide up the work, divide and conquer, right? But we talked about two ways of getting abstraction. Does anyone remember what it is? What are those two ways? Back in time immemorial before the break? Yes, Jason. Yes. Good, good. So abstraction by parameterization and abstraction by specification. Abstraction by parameterization is something very, very familiar to you, probably from 114 or something, right? You sort of carve out, rather than having count male, count female, you might have count population by sex. And so that allows you to count the number of males, count the number of females in a single abstraction, a single bit of code, right? Or you have add vector, which passes two vectors to be added. You can use the same thing here. And by passing them, it avoids needing to duplicate the code to add vectors in many different places with many particular vectors, right? So we, instead of having sorting on different lists inline in the code, we have a routine that will sort you any list you want. And so you'll call it with different lists, right? That's abstraction by parameterization. We create a representation that keeps things as parameters, work to be done as parameters, rather than reproducing the same code with different particulars again and again. But the other thing that we spoke about was abstraction by specification, right? And abstraction by specification is also allowing for modularity. It's allowing for reuse. It's allowing for capturing in a generalized way many cases. But here we're not capturing many cases that differ in like the particular pattern of the variable. Which vector is being added or what have you. We're instead handling many cases in terms of many different what? Begins with I. You separate interface from implementation, right? So we're handling many different implementations that have the same specification. The idea is we carve out a routine, maybe it's a class, maybe it's an interface for a class that it supports sorting, or it supports being displayed, or it supports being turned into a string, or it can be serialized, or what have you. And we separate that interface from the specific implementation that happens to be used in one case or another. And we, by specifying this interface, by specifying an interface at a higher level that's not linked to a specific implementation, you get many benefits. What's one benefit we get from this? By having our routines have the separate interface from an implementation where we say something like this sort of interface. What's one benefit we get from it? I said it handles many cases. And what's the benefit? Change the what without changing this. This will stay the same if even if we change so I welcome tries in that regard, but it's actually changing the implementation. There can be many specific implementations that have the same interface. And if you're using this function, you don't have to worry which implementation is behind it, because you know what it needs to do its job, the preconditions, and you know what, if the preconditions are met, what job it accomplishes, the postconditions, right? And that allows you as a user of this abstraction to use it without depending on exactly how the implementation is undertaken. What language it's written in, which particular algorithm it uses for sorting, for example. Or for, calculating the max flow in a graph or a minimum cut in a graph or whatever. So by providing a specification, this is an interface. It's a contract on which you can count. This is something Ronan was saying. You have a contract. You have an agreement. And that contract means that you don't have to worry about the implementation that lies behind it. Much like having a contract with Furley or Courier to get your package to Toronto by 2 p.m. tomorrow means you don't have to worry about all the details of the flights that have to be taken, who's going to drive it within Toronto or drive it to the airport in Saskatoon. As long as they make that guarantee, you get it to them to ship by 11 a.m. today. They'll get it to Toronto, an address in Toronto by 2 p.m. tomorrow. That's all you need to know. And it means you don't have to worry about refunds. Right? Just like plugs in the wall. There, not far from Connor with a feed. There's certainly one here as well. Those plugs, we don't have to worry about how they're implemented, where the wires go, and so on. All we have to know is that they provide electricity for 120 volts, at 60 hertz. And so we can plug in and use that without worrying about all the details of the wiring. Mariam.
So can you mention it's before test because you can write or test before
Yes. Absolutely. It's in many ways, so wonderful point. In many ways, that's why I'm pursuing this topic before the discussion of testing. Because testing can build atop this hugely. You can write tests against these specifications for something even before the implementation is done, right? And with unit testing, we often do exactly that. We seek to do exactly that. But with system testing, in principle, you could do this as well. But what else does this allow beyond that, beyond people to build up code that uses this abstraction even before it's done, or write tests against this before it's done? Those are wonderful benefits, compelling on their own. But what else does this allow? I'm rescuing data from U.S. governmental sources. I won't distract you with the details of that. What else does this allow? As software goes on, and during the maintenance phase of software, this allows us to change the implementation of this. And as long as you don't change the post condition, given the precondition, you can change that implementation to optimize it, to make it more memory efficient, to make it faster, to be cleaner, right? As long as you don't change that. It tells you as the creator what you can change safely. Because if it's not guaranteed here, like that the sort leads lines to be in the same order, if it doesn't promise that, no one should be coming, right? But conversely, it allows people writing code against this to know that what they're calling won't be changed arbitrarily in ways that break their code. So it has benefits for the creator by giving them freedom, delineating what they can change safely and what they can't, what they have to guarantee. And it gives the people who use this confidence that their code won't be broken by changes to the implementation of it, right? Now, we know the world is not perfect, and occasionally specifications will have to evolve like APIs evolve. But we put a lot more effort to keeping these consistent and changing them very little much less frequently than the underlying code that implements them, right? We try to keep specifications as consistent, as constant as possible. We treat these as contracts that cannot be broken lightly, right? The world's not perfect, and sometimes we do have to adjust them, but we do so with understanding of the gravity of that and the need to let people know, etc. Okay, so we've been talking about this idea of separating interface and implementation. And look, like abstraction by parameterization, this handles abstraction by specification, handles many particular circumstances. In this case, different implementations, in a single way and through a specification. It lets us handle many possible implementations, just like abstraction by parameterization lets us handle many specific cases of which particular vectors we get. We pass them in different values of the parameters. That's one way of getting abstraction, of getting reuse, of getting generality. Another way of getting generality is having specifications people can count on. And there you're allowing changes in the implementation of that thing as long as they adhere to that specification. But defining the interface here is not a small, trivial matter. It requires thought, to create one of these specifications. And you're probably encountering this if you're, responding to my requests to have many of these specifications in your code. And the type signature is not going to be enough. We're seeking, a contract, and I've emphasized that. And I've given a glimpse of this contract, and the last time I gave you a little challenge, to try to have a contract in place. And I gave some ideas for how you can specify a contract. One way, not the only way, is by specifying preconditions and postconditions for functions. And we're going to see, before we finalize this material in coming weeks, some extra information that's needed for classes in the form of invariants and history properties. Okay, these are topics that require more discussion. So, for example, history property will include something that's immutable, or that a value never decreases, that an index always rises, that it always returns successively larger values, larger or equal to its previous value. Or that the number of keys in a dictionary never goes down. Invariants are things that are guaranteed to be true at any one time, like the value returned is always greater than 0. There you're just looking at one point in time and saying this property is true. Whereas for a history property, you're looking at two different values in time and saying how the value of the later one relates to the value of the earlier one. That's the difference. We'll come back to these for classes. I'm not giving a full explanation today. But with classes, you need to reason about this, or you'll be missing certain key information that is needed for a specification to be airtight. Okay, now, these are not the only ways we can specify them. I had mentioned earlier to Connor with an E. That we can also specify things like preconditions, return values, and effects. This is another division. What values I require? That's the preconditions. What information has to be, what the properties are for me to do my job. What things that need to be guaranteed about what you're asking me to do. Like that the values passed to me are not null, or this value of an index in an array is 0 or more, and less than the value of the array, the length of the array minus 1. These will be pre-conditions. Conditions, requirements for the method to do it, right? Beyond that, sometimes instead of post conditions, we instead have return values. What I return, what's the value that I return, and then that's separately from that, we say what I modified or my so-called side effects. Is that term side effects? Things like modify and like I change the symbol table, or I update something on the screen, or I send a message, or I, update a value in the database, or I clear a table in the database. Yes, please.
I was just about to ask, like, if certain examples were what you meant by side effects, and you just listed the examples, so I was about to ask.
Oh, well, glad if there was a confluence of interest there. So a clock is right twice a day for me. Sometimes I'm lucky. Sometimes with learning, maybe not so lucky. Okay. So just be aware these are not absolutely set in stone. These are not the only way you can specify things. They're not truly privileged, but they are a thoughtful way of capturing that. And I want to emphasize post conditions include return values and side effects. So commonly those are kind of wrapped up in post conditions. So we're specifying what we return and what, if anything, we modified. Yeah, and so here, preconditions, effects, and invariants are another way to specify things. Okay. So last time we talked about, gave some examples. You worked on them, and then I gave some possible, for extract substring, right? Where I have a string, and I want to extract a sequence within that string, starting at index start, where index 0 is the start of the string, and going to index final. There's a set of preconditions that are either convenient, like don't give me a string that's null, and kind of sensible, as common sense, sort of reasonable things. That's not something that leaving it out would be unacceptable. It will just mean, it's kind of odd if people are trying to take the substring of something that's null. You could agree that I'll say, I'll return an empty string, but that wouldn't, and maybe you return null. It brings up some awkward issues, and it's kind of a case we'd like to be able to rule out for convenience. But importantly, you might want to say like start is less than or equal to final, right? Doesn't make sense for someone to say, give me the subset of the string that starts at index 3 and ends at index 1. The very notion of start and finish suggests start to be no later in the string than finish, right? Right? And I guess I call it final. Final to be less than the string length. I mean, we shouldn't be asking for the value in the string, beyond its length, right? And it's less than because it starts at 0. So if the string length is 2, you can only ask for index 0 and 1, right? So less than the maximum value you could ask for 1 is less than 2. You comfortable with this? Okay. So this was one example for preconditions, and then post conditions we return the substring of strings starting at and including index start up to and including index final. And notice I do say here in the specification that I'm using indices that go from 0, not from 1. It would be perfectly reasonable to go from 1. I could write this value. I could rewrite this if I wanted to, saying my convention is to start equal 1 or final equal 1 will refer to the start of the very first character of the string. There's nothing inconsistent about that. It's just it's a different convention, right? And we have to choose our convention. We have to make clear what our convention is. Yes. Yes, Holmes.
Yeah.
For the post computer, maybe I will handle it this or I will add this.
Yeah.
to the-
That's an excellent thing to add as opposed to. I'm indebted to you for bringing this up. And I stand remiss for not emphasizing it earlier. Even before the break. So I'm grateful to you for bringing this up. Exceptions are one of the host conditions that we want to mention. They would also factor into effects or, the side effects that occur, throwing an exception. Right? There, the return value is never even returned, right? It's you're throwing exception as an alternative to a return. And that is a legitimate post condition, and you want to make it very clear that that's a possibility. Because you want, well, why would you want to make that clear? Why would you want to make clear that this could throw an exception? Anyone? Why would you want to make that clear? Yes, Alex. Yeah, exactly. If they're unaware, then an exception may be thrown. They may not know to put the need to put a try catch block, for example, right? You're familiar with the notion of exception handler? And absence an exception handler around it, or exception handler associated with that block of code, what could happen? Yes, Connor.
The program could crash.
Indeed. Because the exception might propagate to the highest level, right? And it could shut down the program. So you want to equip the users of this code with knowledge about what it could do. And Hong is bang on right to say one of the most important things you want to equip them with is to know that exception can be thrown so that they know that they should prepare to handle that exception. Now, there are languages. Perhaps you could give me one that require or that can use type to specify what possible exceptions are thrown by this piece of code, by this method or this function. Can anyone mention a language which has some elements of that? Where you can use types to at least indicate a class of exceptions that you thrown? Yes, basically.
Rust.
And then Rust is one, another one. Alex?
I can type it.
I think. I'm not sure about TypeScript. That could well be, and right, if you've seen it before, probably that's the case. Yeah.
Like you need to put there, there's a separate catch box for
Yeah.
there. You can't do that, but then you can do the type of.
Okay, but as part of the characterization of the type of a method or function that you're calling, can you specify this throws this exception?
Yeah.
Okay.
Well, not. Maybe.
Yeah, because that's really the question. When you specify one of these methods, in addition to specifying return value, you would say this can throw X, Y, and Z, where those are possible. Another example is Scala, another example is Java, that allow you to specify this. Now, some of these languages, including Java, and I think by extension Scala, based on the same Java virtual machine, they some exceptions called runtime exceptions are exempted, but there are these ones that are statically described. In other words, that you can reason about it when you build the program, about possible behaviors, and you have to say for those which you can throw, for the reasons that Hong was alluding to. That's part of its behavior. And ones that are not runtime exceptions, you have to say how you how you handle them. You can either have a try-catch block for them that handles them, or you can throw them yourself. So if I have a routine A, three strikes and you're out. A calls B. If B throws, invalid format exception or what have you, invalid format, I can't remember some of these names, exception. Either, so A might be called by X, Y, and Z itself, right, at different times. And either A has to have a try-catch block around a call to B, or we're calling off to B, or A has to itself do what? Either it needs a try-catch block when it calls it to handle this, so catch something that's a super type of, or that's invalid formatting exception or a super type, or it needs to do what? So you can do this, where it catches this exception. It calls this, and if the exception is thrown, it handles it. Or what can it do? What can it elect to do? And still be responsible. What could it elect to do? Yes, Jason.
All I know is that, like in Rust, there's types where you can have the actual value, or it can return an actual exception.
Yes,
Item.
that's right.
So it returns an exception, but doesn't actually stop the program.
That's true. Yes, it returns. We often use the term throws, but it's not universal. It's an exception condition in languages in the functional tradition. This might be by returning an either, for example, where one of the conditions is kind of an error related condition. But either this needs to handle it, or it needs to throw it itself. The same exception. And either one is responsible behavior. Either it's part of, I'm going back to Hong's question, which is just rich with explication, opportunities to explicate it. Like, this is part of, I'm writing something that will be part of the specification. This might say int, this B returns an int and it throws, in other words, it's a possible that it is possible that it throws this exception. And A, when it calls it, either it needs as part of its specification that it can throw this exception, in which case it could just, when it propagates up from B back to A, it just allows it to propagate on to its caller, or it handles it in a try-catch block. You call B, and if this throws exception, it catches it and handles it, like closes the file and closes the database connection and does, deletes the file that was only halfway through being created so it doesn't leave corrupt data on the disk, or it basically tells the user this update failed. Maybe it handles a disconnected network as part of this, and it says, I'm sorry, I couldn't undertake the task, but it doesn't leave it in a messy state. It cleans up after itself. So, per Hong's comment, perceptive comment, specifications should include exceptions. When they can possibly be triggered, we state what exceptions can be thrown by this one. Are we comfortable with that idea? So that will be part of post condition. But it would often be specified in the types of the signature for this, count substring occurrence returns and it takes these two arguments, two strings, two references to strings, and you could put, for example, throws invalid format. And then anything that calls it either needs to throw it itself as a possibility, or it needs, when it calls this, to handle that, to be responsive. Does that make sense? Exceptions are an interesting topic and one which, if class time allows, to which we may return. Okay. Ken, I want to talk some more about specifications. We didn't get a chance to do this last time, and I kind of felt we do well to have some discussion together. So here's one example: index string. So we here, you know, if either one is null, we throw a null pointer exception. There we go. You notice that part of the type signature? Yes, Jason.
I just had a question. So if it doesn't throw an exception but handles it itself in the catch statement, you would put it into your comments as a side effect?
No, good question. So you're saying if as part of this code, if we handle an exception, do we have to put in as a specification in the specification, say for a post condition or an effect of this code? The answer would be
Should document that in its, like how should document that in its?
generally that would be part of the implementation details that we need to see. Because it would depend on which libraries it calls and whether those libraries take care of it itself. That will be an implementation detail. The deal is that what's observable from outside of this code? So if I want to call A, what do I need to know about its observable behavior? That's really a key question. We'll come back to this again and again with the discussion also of behavioral subtyping. Okay. The question is, what aspects of its behavior do we need to know about? And if it happens within its own code to call after something that happens to throw an exception and it cleans up after it, we're none the wiser for it. Like, we don't have to worry about it as the person who calls A, because that doesn't affect us. It's taking care of all the work needed. It's kind of handled the situation that was required. There may be in the future, Jason, it will call off to a different routine that doesn't throw an exception or ensure that the network is connected before it calls this routine, and therefore the chance of an exception is occurring that's a network disconnected assumption has been eliminated, what have you. Then we don't need to worry either way about that. That's an aspect of the implementation detail that wouldn't normally manifest in the specification. If that's helpful. Yeah. I would really like that question. Any other questions related to that? Okay. So let's talk about this. So index string, if S1 or S2 is null, throws an exception. Otherwise, if S1 is the empty string, throw empty exception. Okay, that's interesting. Otherwise, if S1 occurs as a substring in S2, returns the least index. In other words, the first index where it occurs. Otherwise, returns -1. Where -1 indicates it wasn't able to find string S1 within S2. And you'll notice it gives some examples here. This is really good practice in specification to give some examples, right? It says index string BC and ABC equals 1. Why is it equal to 1? Anyone say from this justification. Why one? Why not? Great. Sorry? The least index, exactly. And you notice it's not saying zero, right? Like, it's the first index, it's not saying that it says least index and it's leaving ambiguous actually, whether the least index is 0 or 1. That could be improved. Like it's left out some important information. But BC is that index, the first occurrence of BC is at index 1 here, not index 3. The least index. Are you folks comfortable with this? And you notice it gives another example where, it indicates you can't find it, right? And that's a good thing to do, show a case where it's kind of the normal path we like to think about as software engineers, and the path that it's kind of inconvenient, but we have to handle it to be responsible, right? To not handle this would be negligent. Yes, Jen. Good question. And I'm going to have a lecture where I talk about exactly that. There are trade-offs, and one of the biggest trade-offs you have to recognize is that exceptions can be inordinately, markedly, nay, grievously expensive at runtime. And there's a lot of work that they do. They do heavy lifting if the exception is triggered. Okay. And if the exception is triggered, you have to, I'm going to use the term roll back the stack. So A has called B, and maybe B is called C, and C is called D, and D is called E. And if an exception is thrown in E, and it's not handled all the way back to A, there's a thing called a call stack. Is that familiar from 215? A call stack? Activation records? Is that okay? Not okay, call stack, yeah. So A calls here's the context of A, and it calls down. I'll show the stack is going down. Calls B, calls C, calls D, calls E, and maybe E throws an exception, and maybe it's not handled till A, and so it has to bomb out of here, to use the technical term for it, right? And unwrap this whole stack. Like, okay, D isn't handling it, C isn't handling it, B isn't handling it. All this gets unwrapped all the way back to A, where it finally handles it. And that is a expensive operation on its own. When it occurs, it's incredibly expensive, or very expensive. But more than that, it actually has to maintain the fact that it can throw an exception means it actually has to maintain extra data structures all the way down here that are fairly cumbersome, or cumbersome is not the right word. They require bookkeeping to keep track of as it goes down to E. And so using exceptions, you want to use exceptions for exceptional things, not for things that occur inconveniently but common, reasonably commonly, like one string is not important, it's on the other. Now you could ask, and reasonably so, aren't there gray lines between those two? And yeah, I'll say that, but generally we shouldn't be throwing exceptions frequently. Exceptions should be for things that occur quite infrequently. Like maybe a disconnection of a network will be a good one, or a database connection that was suddenly shut, or an out of memory occurrence, or disk space is full will be another one. These are things which are, exceptional, whereas not finding one string inside another is something you should it's true that it takes us out of our kind of preferred path we'd like to think about as software engineers, but it should be pretty common, and it will often be a common thing. And so we would avoid using exceptions for that. Now, they're good alternatives to that. And there are languages which forego exceptions for lighter weight alternatives. And if we have time in this class, we can talk about it. Monadic return values are one thing. Using things like either to say either you have it's a value, but either you have an exceptional condition, it's marked as a special value, not just using -1, but it's like the returns a maybe within. Maybe I even it, or maybe I have a value that indicates the absence of it, and there is just returning a value rather than having to unwrap this whole stack. And maintain the data structures. But we'll come back to this in a later lecture. Yes, Connor.
Sum or an option for us would be something like that.
Yes, yes. With sums, SOME. Yes. Or an option. That's exactly right. Yeah, in Scala there are options. In Haskell there are maybes, and in some other languages there are maybes as well. And in Rust, some you would say like it's some particular int or it's nothing. Where nothing is a defined value. It's not just -1, which is overloaded. It's not just some weird int, right? It's value that's different. But those are some options for framing. Okay. Here's another example. So we have a counter, you can get its value when you increment the value, right? Notice this is a different style, modifies. What does it modify? Well, the values through this, so it modifies things to which this points, you know, this being pointing to some object, referencing some object. And it increments the current value as its effect. It doesn't return a value, it's void, meaning it, you know, it just does something. We sometimes would call these commands compared to a query, which actually returns value, but has no side effect. It's purely a side effect. This, you know, get, you notice they fold into effects like the returns value. So this is a style of specifications. It's a different style. It's fine. Here's just some considerations to think about in this context. So I'd say the first one is subtly ambiguous. Subset. We have an inset S1 and an inset S2. And it says effect. So F1 or S2 is null, throw null pointer exception. And Tanner's question, really want to throw an exception here. Well, here the exception is almost being used to say like, hey, I don't have the information I need to do his job. It's almost like there's a violation of preconditions, and I prefer that be spelled out as a precondition, but I've shown you other classes here. Returns true if S1 is a subset of S2, otherwise it returns false. Why do I say it's subtly ambiguous? Sorry? You got it. What's one reasonable notion of S1 being a subset of S2? Sorry? So, to be fair to the side one. Suppose S1 is a set with the values A, B, and C, and S2 is also A, B, and C, right? Is S2 a subset of S1? Well, we might say, in normal parlance, people might say, well, really, I mean, is S1 a proper subset? Meaning, does it have all of its elements are in here, but it's not the same as this. But at a technical term, this is a subset of that. It is a subset, and it's not dealing with that distinction. You mean proper subset, meaning, yeah, like, what would be an example of a proper subset of that state? Yes, Connor.
Probably just anything that the subset of S1 doesn't contain all the values.
Yeah, exactly. Yeah, so A, or A and B, or B and C, or A and C, or B, or C, or in fact, the empty set, right? So it doesn't really deal with the possibility. You gotta be thinking, flying ahead of the plan. You gotta be proactive. One of the themes of this course, being proactive, whether it's about risks or thinking about the change, how the system might change, and putting abstractions that insulate you from those changes, like layering or putting in place specification, getting in place your test, being proactive about taking the fight to the bugs, not letting the bugs attack you. If you don't aggressively attack risks, they will aggressively attack you. Yes, Jason.
This is what we're talking about the example earlier, but example two, comments had examples in it, like the specification had examples.
Yes.
That could fact.
That's excellent practice. It's excellent practice. And I'll take my next slide as further examples of that. That's right. Another way is to rephrase it. So you notice the final one is very similar to the first, but it says returns true if S1 is a subset of S2, else return false. That's what's up here. But it says i.e. returns true if every element of S1 is an element of S2. Otherwise returns false. So is it referring to, so this explanation, does that mean the value returned indicates whether S1 is a proper subset or any subset? Is this, so if I gave it these two, ABC and ABC, would it return true or false? True. Good. Or general notion of what we would call a subset mathematically. Here's another example of an explanation that can spot problems and mistakes, actually help safeguard against mistakes in a specification. What's the mistake here? Returns true if the temp is less than or equal to 0 degrees Fahrenheit, otherwise returns false. Well, okay, you haven't phrased it well. Here, the intention is to say below the freezing point of water. If that was the intention, why is this a bad specification of it? It's in Fahrenheit. Yeah, it's 0 degrees Celsius. It's 32 Fahrenheit, right? Why is this an issue with billion? Anyone know? Yeah. Yeah. Rob. Yeah. Okay.
Like, don't worry that
yeah, and maybe in Chinese, that's it.
yeah, like it's kind of different.
Yeah, like one for like 10,000. Yeah, exactly. Yeah, I won't list others, but yes, that's exactly right. But also UK has different. I think even million may mean something different in UK. I think million may be 10 to the 9, or something like that. But by writing this down in two different ways, you can help head off needless misunderstandings. This isn't like testing. This isn't about perfection, but it's about being sensible to put in place extra safeguards if you can that may head off risk. Okay, I want to emphasize a few things though here. Like I've given you some extra examples here, but I want to hit on one or 2 points, which I'd really like to see in your code. So one of them is illustrated by this my read-only dictionary. So my read-only dictionary takes keys and elements. And what is it saying in this specific is this precondition? What does it basically say? What does it say? What's that supposed to be? For the constructive. The side, yeah, keys and elements have to, they come in pairs, right? And the number of keys has to be the same as the number of elements, right? You're specifying the elements to be associated with each key. It's a dictionary, so you're gonna have for each key, a string, you're gonna have a double value. And they need to go together, right? And so the two have to logically be the same size, right? What else is it saying? Yes, Jason.
None of the values for the keys are null or like just an empty.
Yeah, that's right. And what's the second one saying? I equal to J, so there's no duplicate keys, right? You're not listing the same key twice. Like, yeah, again, yeah, exactly. So it's kind of a sensible thing, right? I mean, like, you certainly wouldn't want someone to pass, 2 keys and 3 values. That wouldn't be sensible, right? I mean, it's common sense, being spelled out. It takes a bit of time to read it, but once you understand, yes, each of these is a very common sensible thing. Key shouldn't be empty, key shouldn't be null, or the key shouldn't be a 0 length string, right? And 2 keys there should be no duplicates of keys, and the number of keys should be the number of elements, right? This is something I wanna highlight. I have is occupied key, and basically it says, look, is this key occupied? Like, is there something listed in me as a dictionary where this key has an associated value, right? I tried to write it down in a kind of sensible way here. Returns true if there's some key associated with value B within me. And the key that I'm supposedly looking up needs to be not null. Don't give me a null key, like a null potential key. Like I don't know what to do with that. So that's a reasonable precondition. And the key length should be greater than 0, because I can't look up like an empty string. I don't want to have to deal with empty length string, which would be kind of odd. Although not impossible. Maybe some other reasonable rendition of it would somehow allow them. Get element. Now, what I want to emphasize here is the precondition. The precondition here is different from something I've showed you in other cases. What's different about it? What's different about it? Yes.
Will pass is occupied key.
Yeah, it's occupied. Where is occupied key? Where have we seen that before? Yeah, it's a method. I want to emphasize this is allowed. Okay, so this specification makes use of the specification of another piece of this, right? So I'll be with you just a second here. So for get element, saying get element is string, I'm saying, hey, that key that passed me has to be occupied, and it has to be a reasonable string. Now note that this precondition kind of duplicates that. So strictly, I wouldn't need this first precondition because it's implied by is occupied key. But the point is, you can, when you give the specifications in a class, for example, for one method, but if you get an API, you can say as part of the specification, hey, what the value for the thing being passed to me. You can use another component of the specification to give a criteria for the precondition or for the posting. You could say, after this is called, this is achieved. Like maybe there's an insert key, right? And after that's achieved, the post condition is maybe before it's not occupied key. When I call this insert key, I say precondition is not occupied, meaning it's not in the read-only dictionary. Or it's not in the dictionary, yeah, it wouldn't be a read-only thing. But then for the post condition, now it is occupied, and that wouldn't be for read-only. That would be related. Yes, Ali?
Yeah. What if there's occupied key for the function in another class, like in another file?
That's fine. That's fine. As long as it's specified. As long as it's specified. It's part of the specification. Here's another case, integer set. Okay, I'm gonna, set a minute. 0, 3, 443. Right? 2, 3, 5, 7, 11, 13. What's the name? 7. Fine. Okay, so anyway, has, so integer set has, you give it an integer, tells you whether or not it's in the set, right? Insert. You notice the precondition for it. I'm just driving this point home. You notice the precondition. What does the precondition say? It's saying that it's not in the set. Yeah, it doesn't happen. It ain't in the set, right? And what's the post condition? It is in the set, right? That makes sense, right? You when you insert, in order to insert it, it's not there, and now once I've done inserting it, it is there, right? Remove. What is this thing? First of all, what's the precondition for remove? Does it require that it be in there? No. What's the post condition? That's no longer, it's not in there. So if it were in there, it's gone. If it wasn't in there in the first place, it's not there now, right? Okay, so I just wanted to emphasize this to you. This really simplifies your life in some ways. The fact that you can refer between these two, and often they have to play together nicely, right? Like these things have to be defined so that they cohere, right? And it makes sense that one uses the other in these ways. And I would encourage you in your, whether it's in your API, your layers between your business logic and your front end, or business logic and your data layer, a persistence layer, or whether it's in a class or other functions. When you give a specification, think about some elements of the specification making use of other elements. That's perfectly good. It's perfectly fine, and it allows for a certain clarity of thinking with respect to it. Because often this gives guidance to the developer, right? About how they can check, for example, the precondition, right? Before calling this, I could say, does it have it? And when I'm gonna call insert, I can know, before I call this, I better check it doesn't already have it. Because it's part of the previous that it doesn't. Does this make sense? Okay. That's all we have time for today. We good? Okay. So thank you very much. Thanks for bearing with me, having to be a bit distracted. And I will remember tutorials